Now that you have finished your project on calculating how much money you would have to pay to purchase a couch on savings and how much you would have to pay if you used credit to purchase your couch, we're going to look at a couple of methods that do most of those calculations for you, and they are annuities and installment loans. Now, the difference between annuities and the compound interest that you did for the SOFA, for the savings account, for example, will be that for the annuities, you don't get the answer of how long it will take you to save up. Now, what we did by hand and putting in our payment each month and increasing our amount of savings account, that's what we do with the annuities formula. And so it's a handy way, if you know how long you want to keep your money in, then you can use this formula to calculate what your final balance will be making a regular fixed deposit every month or every year, however you end up doing it. So for the annuities, we start by making payments. Each month or each year. And then at the end of some amount of time, then at the end, we get a lump sum. And it's usually a very large lump sum because we have interest adding on as well as our payments adding on to the balance every month or every year or however often you're doing your compounding. So there is a formula, and it's the most complicated that we've done so far, but we'll use a lot of techniques that we've used already, plus I'll show you how to use the store and the recall buttons again on your calculator, and you can use those to help you. So first we'll say F equals L times, and then it's a big quantity, so we use the square brackets, and then we have 1 plus little p raised to the teeth power minus 1, all of that over little p in the parentheses. So we need to have our little p defined. Our little p is our standard R over N. So our little p, remember we looked at that before, is the periodic rate. And then our capital T, that's going to be the N times T, and remember that is the total number of payments that the person would make, or the number of compoundings times the time, the number of years, so it's the number of payments or deposits that you're going to make, or the number of times you're compounding. So these are the little p and the big T that we've looked at before, but we haven't used them very much, and that's what's all inside the parentheses here. Now the capital L has two possibilities. The first one is L equals the capital P, and that means no interest on the final payment. So if you're making payments at the start of every month, and then you make your last payment on, say, January 1st, and then you're going to take out your money that same day, so you don't get any interest on that last payment. That's the idea with if L is equal to the P. And the other possibility is that our L would be P times the quantity 1 plus little p, and that would mean that you're getting interest, so we would have interest on the final payment. And an example of that is, say you put money in at the start of every year into your IRA or your savings account for retirement. You put money in at the start of every year, and you put it in on January 1st for this year, and you don't take your money out until December 31st of the following year. So your whole year you get interest for that last payment. So your last payment gains a full amount of interest. And in that case, you would use this P times the quantity 1 plus little p. So you have two possibilities for your L there. Okay. So here's an example that I'll work through with you so you get the idea of what we're doing here. Starting at age 25, Marcus invests $2,000 at the beginning of every year in an IRA, which stands for Individual Retirement Account, and it's a savings account for retirement, and it has special tax benefits, so people like to use those to save for retirement. It has an APR of 7.5% compounded annually. How much money will there be in Marcus's retirement account when he retires at the age of 65? So we could take 65 for when he retires minus 25 and get 40. And then we know he has his money invested for 40 years total. And then here it's also telling us that assume that his 40th and last deposit generates interest for 1 year. So since he's putting the money in at the beginning of the year, he must be taking it out at the very end of the year. So he's getting interest on his last payment. So we have to take that into account. Our formula is going to be this F equals L times the quantity, 1 plus little p raised to the capital T minus 1 over little p. Now we do know more information, and that is for his final payment. It says he will get interest for 1 year, so I'm going to need to use this, let me show it in red, the second L right here, the P times the quantity, 1 plus little p. So I do need to use that instead of the L, so I'm just going to just erase that L and put in that P times the quantity, 1 plus little p. So I have big P times the quantity, 1 plus little p. And you can see how this can get very complicated very quickly. So before I can sub anything in on this formula, I do have to figure out my little p and my capital T. So my R is going to be that 7.5. So remember, little p is R over N, so 0.075, so change it to a decimal, divided by my N, and it says compounded annually, so I know my N is going to be a 1. And so that's just going to make that one really easy, 0.075 for my little p. And then my capital T, that's the N times T, and my N is 1 still for annually, and my T is how many years, and it is 40 years, and we found that 2 ways. One was 65 minus his ending age minus his starting age, so 40, or right here it said assume his 40th and last deposit, and he's making deposits 1 time a year, so 1 times 40, and that should come to the number of deposits that he makes, which is 40, and so we know that our T is 40. Sometimes that's given to you a little bit differently, like you might have payments every month, and then it'll tell you assume his 360th payment or last deposit, and then that would be your big T. It would be the 360 because it's the actual number of payments that he's made, not the number of years that he is making payments for. So back to this problem, we have F equals my capital P, that's the payment amount, how much he's depositing, and that's the $2,000 that he's starting with, times 1 plus my little p is 0.075, and then my big bracket, and I have 1 plus the little p again, 0.075, raised to the capital T, which is the 40, minus 1, all of that over little p, which is 0.075. Okay, now to calculate this, we definitely want to use our calculator, and we definitely want to follow the order of operations. So I see these big parentheses here, right here, and right here. So I know I need to work inside those parentheses, and then within them I have another little set of parentheses here, so I need to take care of this before I handle that exponent, and exponents come definitely before subtraction, so I'm going to need to take care of this addition, and then the exponent, and then the subtraction, finally this last division here. That'll take care of my whole inner part of the big parentheses. I have a little bit I have to handle inside of these parentheses, and then multiply and multiply here. So I have a lot of operations, so I'll show you working through that every little step. And let's start with the first calculator in the line here, the ink blot calculator. And so we'll hit clear. The first thing I want to do is handle the inside this little parentheses, 1 plus 0.075. Now I know that one because it's really easy, so I'll just write 1.075 right above it, and I don't even have to plug that in. I can also do that over here, 1.075. So I've got two little pieces done already, but I am going to have to do that 1.075 to the 40th on my calculator. So I'll put that in, 1.075, and there's my to the button for this calculator, to the 40th, and push enter. Now I got 18.04 something. The next thing that I have to do in that numerator is subtract 1. So I have that sitting there on my calculator. I can write it down definitely, 18.044, and it goes on minus 1 over 0.075. And then here I have the 1.075, and here I have the 2000. So this one, because we don't have anything special going on, I'm going to be able to do it without using the store and the recall buttons, so I'm going to just finish showing you that way. So I have the 18.044, I need, that it goes on and on, I need to subtract the 1, so I'll do that next. Minus 1, enter, and so I get the 17.044, no big surprise there, so 17.044, and it does go on all over the 0.075. So I'm just writing down little piece by little piece so we can see what I've done. And divide now, so I'll do the divide by 0.075, enter. And for the big brackets now, I can change them to little parentheses. I have 227.25, and it does go on and on, so I'll put the dot 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 there. And I still have to multiply by the 1.075 and by that 2000 out front equals my F. So next thing, it's just 3 multiplies. So I have the 227.25 on the calculator, so I'll multiply it by 1.075 equals, and then one more multiply times 2000 equals, and there's my F, my future value. My F equals, and it's money, so I have 488,601.517, so it'll have to be 0.52, and I'll put a comma in there. Remember, it goes 3 decimal places, so there's my comma right there. Now what this is telling me is that if I deposit, let's go back up here just a little bit, if starting at the age of 25, Marcus deposits $2,000 into his IRA every year, so once a year at the beginning of the year, and he can earn 7.5% compounded annually on his account, in 40 years when he's ready to retire, he's going to have $488,601.52 for his retirement if he just puts away $2,000 at the start of every year into his IRA. So this annuities formula gives us the final balance if we are making regular deposits every month. And that's something that we had to do by hand before using the compound interest formula. But remember, the compound interest formula is best if you have a big chunk of money and then you use the formula to compound your interest every so often, put all that money back into the account, and then you have a bigger chunk out at the end. The annuities formula starts with a small deposit, and you add the same size deposit every single month or every single year until the end of the time where you're investing, and then you have a big huge chunk out at the end. So there's no big chunk to start with annuities, it's just a regular payment or deposit that you have.